Hello again, and welcome to the second roundtable discussion of the day. I would like to introduce Keith Anderson, Chairman, E-Waste Association of Africa, who will moderate the battery recycling roundtable on resource efficiency that will address the challenges, opportunities, and future trends in battery recycling. Keith Anderson sits on the board of numerous companies. He is past president of Information Technology Association of South Africa and is currently chairman of IWASA, which he founded in 2006. He drafted the first industry waste management plan and submitted it to DEA in 2010. He is a sought-after public speaker locally and internationally on e-scrap management and circular economy. Keith has also launched the Africa We Forum with the objective of establishing a uniform e-waste standard throughout the country. Over to Keith.
Thank you very much for that introduction, and welcome to the team. And thanks to the organizers for putting this all together. I think it's certainly a very pertinent subject, and it's great to have such a group of distinguished gentlemen representing the various sectors, and it gives us a nice balance. What I'd like to do to start off with, if you could introduce yourselves, I suggest if we go clockwise, starting with John and then circulate around and ending up with Justin, if you don't mind. John, over to you.
Hi, good morning, all. My name is John Warner. I'm the Chief Customer Officer at American Battery Solutions. We are a United States-based pack manufacturer working with all of the major cell makers in the world, really focusing on lithium-ion battery packs for everything ranging from autonomous robots all the way up to trucks and buses and entering into the grid energy storage space. So it's a pleasure to see you all.
Great, thanks, John. Leon?
Hi, everybody. My name is Leon Farrant. I'm the CEO and co-founder of Green Lion. So we're a clean tech company, and we've essentially built a technology that can take in spent lithium-ion batteries and rejuvenate them back into battery-ready cathode material, ready for brand new batteries. So I'm really pleased to be here, and thank you for having me.
Great. Thanks, Leon. Raman?
Good evening, everyone. I am the Managing Director of Exigo Recycling Private Limited. We are an e-waste recycling company that's completely integrated both in terms of collection to the last mile recycling. We are based out of New Delhi, and currently we have 3 plants in the country, and we are going global, coming to the Middle East as well. And for the past 2 years, we've been operating a battery recycling plant wherein we have developed solutions, both mechanical, hydrometallurgical, for the recycling of lithium-ion batteries. And within a couple of years, we plan to be able to extract battery-grade materials from the recycling process.
Thanks, Raman. Justin?
Hi, nice to be with everyone. My name is Justin Lamont. I'm the co-founder and head of international operations for Loham. We're based in India and the United States. We are a battery lifecycle management company that does first life and second life on the battery manufacturing side. And then we are a full cathode and anode recycler on the recycling side.
Great. Thank you very much. So now the stage is set. So the theme of the discussion this afternoon is battery recycling, the roundtable, specifically focusing on resource efficiency, challenges and opportunity and future trends in battery recycling. And as I'm sure everyone will be aware of, the fact that technology is always changing. And yes, we're very good at creating new devices, but very often we don't spend much and pay much attention to what happens when it becomes end of life. And the battery side is no different. And it's always been one of the dark side of recycling. People didn't want to get involved in it because it's a dirty business and there's no money to be made and all the other challenges that go with it. So it's going to be great to get the inputs from yourselves as to what you've done and what you've done well and why you do what you're doing. So if we consider, and I'm going to pose the questions as open questions to the panel, and then we'll discuss it randomly. So if we consider the shift in approach towards circular models, which is the buzz at the moment, and the tremendous increase in the volume of battery-powered phones, EV vehicles, and other electronic devices, what are some of the important opportunities that exist in the battery recycling space right now? John, would you like to
Yeah,
go first?
why don't I start? So, and I'll speak largely from the North American perspective, and even largely around the motive application and perspective. In the U.S., we've seen electric vehicles in the marketplace for about 10 years now, and what you find is the life cycle of a vehicle is about 10 to 15 years. So we're just seeing those first batteries starting to come into the recycling stream. So, we're still developing, I would say, the infrastructure. I know there's a lot of work going on right now. The U.S. Department of Energy just put a recycling prize together about a year ago, trying to help encourage battery recycling in the U.S. But from the North American standpoint, we're still in the very early stages. There are several companies who have made very good progress. But I think the infrastructure is still one of the areas where we're kind of lacking in North America.
Okay, great. And before I go on to Leon and Raman and Justin for their comments, so just another secondary question to keep in the back of your minds is we've seen huge investments by companies in particularly in the EV space, setting up huge factories to manufacture batteries. So I'd just like to know, how does that tie into what the panel is doing, and what's the continuity, and has there been collaboration and discussion around that? And I'll come back to that as a secondary question. Leon, would you like to give some comment?
Yeah, I mean, maybe tackling that second question first. I think that certainly poses an opportunity, as we all know that all manufactured batteries aren't fit for distribution, and there's waste product there. And I think that we're finding some really great opportunity with battery manufacturers and OEMs who want to capture that waste and rejuvenate anything that comes out of their process that cannot be sold and used, and rebuild brand new battery cathode or brand new battery material and put it back through the cycle. So keeping that circular sort of rhythm. I guess the other opportunity that we see is that manufacturers and OEMs are now more worried than ever about the supply and of raw material and controlling that supply chain. And so they're looking to recycling, not maybe for the environmental aspects and whatnot, but it's more about being the winner at the end of the day and capturing that raw material in the lowest impact way. So without having to own your own lithium mines, cobalt, and nickel and whatnot. So there's many opportunities in this space currently, I would say. Yeah, absolutely. We'll come back to that because it's a good point you make. Raman, would you like to add to the conversation?
Yes, especially from the Indian perspective, still the EV penetration in the Indian market is on the lowest side. It is at this nascent stage, but there are some homegrown companies as well as some collaborations with international companies for setting up of large manufacturing of EVs. And the recent change that we have witnessed within our country is that the policymakers now are leading the show. So what that has done is, I think I am very optimistic about it, and our company is very optimistic that it is going to create an environment that's going to reward battery recycling beyond the economic incentives. So for a country like India, there's a lot of local demand, one of the primary strengths of our country. And especially in the two-wheeler EV space, there's going to be a lot of demand for battery packs and battery manufacturing and vehicle manufacturing. And I think these metals like cobalt, nickel, lithium being of extremely strategic importance for the country, the policymakers have now, picked up their pace and have introduced certain policies starting this year, which is creating a lot of opportunity for recyclers and definitely making sure that recycling can be looked upon beyond economic benefits that exist. Because I don't think that every chemistry, especially in a country like India, where there's a lot of penetration of lithium iron phosphate batteries that yield very low recycling value. So policy making, because of these large investment on the manufacturing side and putting together battery packs and the interest that is there in the market now, I think it's creating a lot of opportunities on the recycling and reuse side.
Right. Yeah. Thanks, Ron. Good point. Justin?
Yes. So my view is obviously everyone on this call, right, and what we're trying to do in general, right, is one, transition to a low carbon environment, particularly around that supply chain is critical, right? So this shift, this industrial shift, largely by all accounts, will be the largest and fastest industrial shift that the world has ever experienced. You know, if nothing else, because for the first time, the entire world at the same time is trying to go through this transition, right? But there's no historical precedent around that, right? So one, how do we do that with speed, right? And that's certainly going to happen on the front end, right? But if we just solve it from a speed and a you know, call it a first life solution, essentially, where we are creating electric vehicles, we're creating storage solutions on the stationary side, and if we don't sort of move to that circular economy, right, from the supply chain and the resource utilization standpoint, then we've essentially shifted, but we've shifted to a historical model, right? And so I think that's the largest opportunity around recycling, right, is it's key to lowering the footprint, and it's key to resource utilization, which in most countries, they're facing the same thing, very, very low, zero or no reserves for critical materials. And then just as it relates to whether it's emissions or supply chain efficiency, access to raw materials is critical, right? So we have this opportunity that is really interesting. And I think to John's point around infrastructure, I think at least, you know, when I look across the globe, the infrastructure is nascent everywhere, right? So we're trying to solve this transition from both a technology standpoint, but also an infrastructure standpoint. The only one that potentially is a little bit out in front of this is China. Everyone else is essentially at the same point. So there's a lot of excitement and enthusiasm around the corner. It's just how we're going to get there.
Yeah, thanks. I think you gentlemen make some really interesting points, and I just want to drill down into them a little bit now, specifically around the infrastructure, because as you rightly say, China seems to have jumped the gun, and they already have the infrastructure or a large part of the infrastructure already in place, where the rest of the world seems to be playing catch up. That's my first question. Is that in fact the case? Secondly, how, because as I understand it, the investments that is required to put up a proper treatment facility can run into some serious numbers. So, and given that the EV, and particularly in the lithium ion side, is only coming to its fore now, how do you go and spend, $20 million setting up a facility where you're going to have no feedstock for the next year or so? So, that's a fine balance. I'll put that as an open question. How do you deal with it?
And that's, I'll tell you, in the US, that's been the real challenge, right? Is the people that are investing now are the people that are investing for the future, because it is, and it's more than a year. It's likely 5 to 10 years, right? Because as I said, you've almost got to look at what's coming into, from an automotive standpoint, what's coming into the recycling stream today are vehicles that were built in 2010. In the US in 2020, there were 3 models. You had 3 choices, right? You could buy a Volt, you could buy a Leaf, or you could buy a Tesla Roadster. That's it. And altogether in 2010, they sold about, 40,000 vehicles maybe. So depending on what got lost between then and now, those are the ones that are just starting to hit the recycling stream. So you've got to have an investor who is willing to look at this from a long-term standpoint and be willing to think of it as developing an infrastructure.
Yeah, exactly that. I was going to come back to a point that Raman made, and just to add on to what you just said, John, because so you've made a good case. Interesting, when Raman commented, he said, and now speaking from an Indian perspective, in India, they see a big opportunity in the EV space, in the two-wheeler side, because of the large number of scooters and so forth. So I would imagine, Raman, you would be putting up a slightly different looking facility than kind of a John might be doing, and do the two meet, and what happens there? I think you muted, Raman. Just
Sorry about that. So Keith, right, that's a very valid question, but I think the upstream process can look different, but as far as the hydrometallurgical side of things is concerned, or some organizations across the world, for example, Umicore in Belgium, they use a pyrometallurgical process. Eventually, the feedstock is converted into a form that fits into the facility very well, regardless of the source. And I think in the longer run, it is going to be a big advantage if you have chemistry agnostic or at least form agnostic solutions in place. So yes, a facility that's more focused on the four-wheeler side, because we have batteries that weigh anywhere between, let's say, 400 kilograms to almost 900 kilograms or up to a ton, for example, depending on the vehicle, the source. In India, we are only now, getting our hands around battery packs from high performance vehicles like the Mercedes vehicles that have been introduced. So we recently got our hands on a battery pack from EQC that weighs around 660 kilograms, if I'm not wrong. That's an 80 kilowatt hour battery pack. So we need to have, we need to adapt and develop very different apparatus to handle the discharge, to handle the dismantling and then downstream processing of these batteries before we start feeding this material into the hydrometallurgical and resource recovery plant. So probably downstream it will look the same, but yes, in India, our primary focus will be on two-wheeler batteries. Those are smaller batteries. The apparatus to handle the risk involved, the logistical challenges involved are different compared to a developed nation like North America, where you are primarily going to rely on large volumes from the four-wheeler segment.
Okay.
Yeah, maybe I'll just jump in here real quick,
Yeah.
Keith, just because we're across both the, I see we have operations essentially in the US, certainly in India where our headquarters is, but then we do a lot of business with Europe as well. I think on the front end side, on the investment side, so certainly there's a consideration for an ROI as you're building a plant, right? I think the key is one, what kind of capacity do you need? Is the plant model modular, right? In the sense of there is a sort of historical model where essentially you can only be profitable by a very, very large capacity plant. And I think our focus from day one is how do you build very modular capabilities? Certainly, it's profitable, but at high volume. But how do you get to low volumes, right? And ensure that you're profitable in that regard. As far as the process goes, we see very kind of very similar systems, right? I mean, what we've built in India essentially is going to be the same thing that we are in planning stages and will build in the US in 2022, right? There is a different feedstock, right? To a degree from, as Raman noted, there's a little bit different mobility ecosystem, right? In India compared to the US, right? But there are a lot of, you're just going to have the reverse happen, right? So there's going to be, the first streams are going to be large four-wheeler batteries, but there's obviously batteries coming from a lot of other places, right? Both in the US and India on the telecom side, on the data center side. I think the disassembly process on the front end is very similar because you just have to break it down to the module level. So whether it's a two-wheeler pack, whether it's a four-wheeler pack, right? Figuring out that process is very similar, right? Standardizing it is hard, but that process is very similar. And my last point would just be, there is a lot of cathode scrap out there, right? So every time you build a cell manufacturing plant, which, I mean, just in the last month in the US, there's between Stellantis and Ford and Toyota, I mean, there's probably another, over the next 5 years, almost 300 gigawatts that have been announced, right? Between those, right? So, and that is, roughly sort of 8 to 10% of that capacity, right? Is cathode scrap that's gonna come out every single year, right? So that is one source that is starting to become very significant and largely what people will see as a large part of feedstock over the next few years.
Okay. Yeah, thank you. Leon, anything you want to add to that?
No, I would just echo the points of my panel members. I think that we're a little different. So we're not running a recycling plant. We're only a technology company. So we're licensees of the technology that we have patented. And the key thing that we try to focus on is supporting recyclers to, just like the other panelists said, take in chemistry agnostic black mass or mixed battery loads. So it doesn't matter where it comes from. It can be consumable batteries, a Tesla or a ESS battery cell, and then make sure that the system, exactly like Justin was speaking about, is make sure it's modular. We can start small, keep it profitable at anything above 100 tons, and build on that. So I think it's really important. I think that Justin and Ramon really nailed it.
Thank you. So my question is, that comes from that discussion is, what happens at the moment? Everybody's gravitating, and rightly so, towards EV lithium-ion type batteries. That is the future. I think we accept that. But what happens to all the multitude of historical single-use batteries that exist, from small portable batteries in your torches to button batteries in toys and so forth? What's going to happen to those?
Let me jump in there.
Go ahead, Ramon. Sorry.
Yeah.
Fine. So I think, again, this is a very important aspect to address. But currently, speaking from the Indian perspective at least, and basis our experience, I think it's going to be a very big challenge. The waste stream is extremely heterogeneous, and at the end of the day, we are dealing with a lot of chemistries, that are non-lithium ion. So we have nickel metal hydride and alkaline batteries and cadmium batteries and so on and so forth. And we are speaking of legacy waste from an era where there was no standardization. So in terms of labeling, in terms of packaging, in terms of conformity to size, shape, etc. There was very little standardization, especially from the perspective of developed nations. So this has been a challenge, and I think currently, based on our knowledge, there are very few solutions out there that can efficiently, I would say, enrich these waste streams and make sure they can be channelized to proper recycling facilities. So I think we all need to work around developing a solution for this, and it's a very big challenge.
Yeah, thanks. Anybody else want to add anything to that?
So I would just add that I agree with Ramon entirely. The other challenge I think we face is collection of those primary cells, of those other cells. At least here in the U.S., I don't know that there is very clear streams for what to do with those. I think a lot of them get thrown in your general waste rather than getting properly brought into a recycling stream. So I think that there's some development that needs to happen there in order to even consolidate and get all of that into a good waste stream.
Yeah, and I would just make one additional point. I think one of the things that we saw, and there's sort of two differences. One difference that will change, or certainly the goal is changing as relates to historically, as we've seen with e-waste, there was, essentially you could go online and talk to different people, and everyone was essentially an e-waste recycler, right? And that there are tremendous amount of nuances in recycling capabilities, right? I think that because the streams are going to be so much, once more significantly in volume and have become very strategically important, right? Then you're going to see a huge shift, right? Particularly from a policy side and an auditing side, right? Around what actually is your capability, right? Regarding safety, regarding recovery efficiency, regarding environmental footprint, regarding emissions. I think a lot of those things that haven't historically played a role in traditional e-waste recycling, right, are front and center, at least as we see it, on the go forward with recycling as far as this transition goes with high voltage batteries, larger batteries. And I think to John's point is that, you know, it goes back to the infrastructure as well, is that you can't have a car battery laying around your house, right? You can't have a 60 kilowatt hour pack just hanging around your house, whereas you can have plenty of old laptops and it doesn't really move the needle, right? So I think from a safety and a volume of material standpoint, that infrastructure again is going to be a critical point, because really no one knows how it's going to evolve, right? It's not like, it's very unclear where are those waste streams going to come from, right? Most of the time they're going to be out of warranty, so they're likely not going to go back to the OEM, right? So how that evolves will be very interesting.
Yeah, and that leads me to the point. So, for example, in South Africa, as of Friday of this week, 5th of November, EPR, Extended Producer Responsibility regulations come into effect. So everybody's running around now trying to figure out what the obligations are and how they're going to deal with it and so forth. And so that, and then specifically, and in South Africa, they've done a few things very differently to the rest of the world. So firstly, they've separated lighting and batteries from the EPR regulations under EEE. They said, no, there's a separate set of regulations for lighting, and there's going to be a separate set of regulations for batteries. As be that as it may, that's what they've decided to do, and we've advised them that they think it's they're just creating a further confusion, but be that as it may. My question to the panel would be, both from a PRO perspective, as a manufacturer, as a recycler, what should we be telling consumers how to handle their batteries, be it EV batteries, be it the inverter batteries that they've got, be it the small disposable batteries, both from a disposal point of view, both from a transport point of view, because you know, you read so much, particularly around EV batteries being transported and bursting into flames and all the rest of it. So what do we have to do to embark on a sort of an education campaign for the wider community?
So I'll start us out here. You know, I think education is exactly right, Keith. I think, you know, globally, you know, there's going to be a need to help educate people how to handle things. On the EV side, I don't think it will be quite as it will still be some education needed, but you've essentially got a vehicle which is going to be going to a recycling or scrap yard at the end of its life, or going to an OEM. So there's a more centralized, I think, location for those. For consumer batteries, though, and other types of cells, that's where I think we'll need a lot more education. If you've got you know, a home energy solution, right, and it comes to its end of its life, how do you dispose of those batteries, and how do we transport those? You know, if a battery is damaged, typically under UN regulations, I've got to ship it into a special container, right? Consumers don't know anything about that. We're actually working with some distributors now, partners. We're having to educate them on how to ship warranty and potential damaged things back to us, because they're used to just throwing a lead acid onto a truck and driving it away.
Yeah. Exactly that, and that's our biggest concern, and I'm just speaking from a South African perspective, is around the transport of those batteries from the field to a central point for pre-treatment or post-treatment. You know, it's a challenge for us. Yeah.
I think the other difference would be is that the economics are different, right, and the incentives are different, right? So in the case of, I don't, to John's point, I don't think it's going to be a real challenge on the mobility side, because you're essentially going to take that vehicle or to either the the dealer or some sort of service operations effectively, right? You might deal with, the consumer might deal with it at a residential side from a storage or inverter standpoint. But there again, I think the economics are changing where people are, similar to when you turn in your phone, right? There's value in that phone, and people determine what is the residual value of that, right? And so there's both an incentive for the individual to get rid of it properly, and there's an economic incentive for them to get rid of it properly, in the sense of, instead of everything just being disposed of in quote unquote a responsible way, right? There's always an additional incentive if you can pay them, right, for that material, right, to then be recycled. And so I think that economic incentive is what you're going to see that's different, right? Is that those that can pay for that feedstock, and those that can have the best economics will also provide the consumer the best economics on disposing of it in a responsible way.
Yeah, thanks, Justin. So if I said to you, I mean, what would be the three biggest hurdles faced by a battery recycler? What would they be, and would they be common?
So in my view, I don't know if they're common necessarily. I think that the way we think about it, right, is we think of it as sort of three, call it like three lenses, right? One is standardization, right? So from a process standpoint, you have to be chemistry and form factor agnostic, but essentially, how do you standardize 80 to 90% of your process so that you've got only 10 to 20% of your process is customized, right? And so that circuit, right, on the hydrometallurgy standpoint, right? Let's just remove the mechanical standpoint at this stage, but that circuit has to be super efficient and largely automated, right? And so there's even within the large buckets of chemistries, right? And if NMC, NCA, LFP, like there's a lot of nuances in those chemistries as well when you start dealing with those, right? So how do you essentially standardize the process as much as you can, right? And then you customize a little bit at the end from an output standpoint for your customer, depending on what they want, right? That's the other thing, is there's always little nuances, right? Of what type of sulfate do they want? What type of purity do they want? Things like that are very hard to do, and where I think the sort of the leading recyclers, that's where they are, and that's sort of how they're thinking about it. The second lens is just emissions and environmental closed loop process, right? So you have to be low power, right? Super low emissions, right? So instead of pyro or other examples, right? Or even just a high, thermal treatment process at some point, right? How do you, for the most part, do everything at essentially a room temperature, right? And regarding your reagents and solvents and things like that in your chemical circuit, how do you make sure all those are environmentally friendly? How do you ensure that there's no wastewater, that all that gets recirculated back into the process? So essentially, you are creating a closed box that essentially is, for the most part, standardized, right? And so that's sort of that environmental and emissions footprint is the next one. And then just it's pure economics, right? So how do you, on the front end, create a plant to our previous discussion, right, about what kind of capacity does it need in order to be economically viable? So how do you construct a plant that is the lowest capex per ton? And then on the output side, and that's really what drives the economics, is that what you produce on the at the end is really what determines whether you're profitable or not, right? So if you can produce sulfates and lithium carbonate, and you can take both the cathode and the anode materials, you are you are profitable, right? Across the chemistries except for LFP, right? So that sort of economic viability discussion is kind of moving out the door, because it's just going to be based on competition going forward, right? So the sort of devil's in the details is that if you have a willingness to pay that's higher, then either you're making a smaller margin or you just have a better process on the output side, right? And that's what I think is starting to come to fore as to the different technologies and what's out there.
Okay. Yeah. Thanks.
Should I go ahead?
Yeah, Roman. Yeah.
So one of the things that we have personally noticed is in terms of strong integration there, because especially in a price-sensitive market like India and many other similar markets, I think it is extremely important to offer a decent, acceptable value to a very high-value primary product in terms of recycling, and especially from the EV side. It's not necessary that all of the individual components or the cells, for that matter, are completely spent and cannot be reused. And a lot of panelists would agree with me on that. So there has to be a very very strong integration between the reuse aspect, and then we need to work on creating offtakes, which I see as an opportunity, especially for a country like India. We need to lower the access point in terms of technology using the secondary cells. So that's one challenge that we feel currently exists, but definitely we're optimistic. There are a lot of solutions, both within our organization and other organizations like Loham and many other organizations globally, that are working in this direction.
Yes. Yeah. Thanks, Roman. We've just a whole lot of questions have come up in the chat box here. I just want to quickly go through one or two of them before we run out of time. So the first one was, and I think you were touching towards it on the end there, Roman, is any further insight on battery recycling markets other than EV? So is there opportunities outside of EV for battery recycling in terms of secondary raw materials or whatever? I don't know. Is there?
I mean, I think being primarily an e-waste recycler and coming from there and approaching the battery recycling of things from an e-waste perspective, yeah, in terms of reliable sources, I think e-waste is one of those. So there's an opportunity in integrating with various e-waste recyclers, plants, and waste streams, electronic manufacturing facilities. Another source could be in terms of what has already been mentioned from the cathode manufacturing side of things. So that's a readily available stream in terms of battery recycling. But I think what we have witnessed is, other than EV, and we do have experience there, the electronic side of things or the IT side of things and telecommunication, they're also quite dependable sources for battery recycling. And especially from the e-waste side of things, I think battery recycling is, for most part, highly profitable.
Okay, great. Another question we received is, why do we not expect the OEMs to develop the recycling processes parallel to the development of new battery chemistries? Does that happen where you work with the OEMs as a recycler?
Yes, I might jump in there, Keith. I mean, we work with a number of OEMs that are looking to develop their own processes, and they want to do so to, again, touching on my previous point, capture that supply chain, that supply of their own material. So not only recycling their own batteries, but capturing a raw material supply. So they're certainly working on it at the same time.
Okay. Yeah. Thanks. Yeah, Justin.
Sorry, I would just add on to Leon's comment. I think that I think what we see is some OEMs want to vertically integrate, right? So they want to develop some in-house capability, right, or a strong partnership with a recycler. I think the challenge is that, and then in addition to that, we see a kind of across the board a very deep interest in Second Life and how that would work, just because it benefits whoever has the feedstock from an economic standpoint, but also has the greatest emissions impact, right? From reducing carbon carbon footprint, but every OEM is approaching it slightly differently. I think that the challenge is that as we see with most things is that the volumes are really slow, slow if you think of from an OEM standpoint, right? Their production volumes. And so I think that is what's challenging in the sense of it's so nascent, right? It doesn't matter which OEM you are, which geography you are, it's so nascent that people are trying different models to sort of see what works the best, but there's no clear path other than they want to maximize their efficiency, right? And figure out how to regionalize it to a degree if they can from a supply chain standpoint.
Yeah, thanks, Justin. John, did you want to say something?
Yeah, I was just going to add the other half of that is I think that the cell OEMs are getting involved from the incoming materials, right? So if you look at the growth of lithium-ion batteries over the next 10 years, right now the 2030 forecast put the demand for lithium-ion batteries at somewhere, depending on which forecast you read, which one you believe, but somewhere between 1.5 and 3 terawatt hours of lithium-ion batteries. Recognize we're about 380 or 400 gigawatt hours today. So if we're going to hit those numbers, the question is, where is that raw material going to come from? And part of that answer is going to have to be recycling. So I know that a lot of the cell makers are engaging with the recyclers directly because they're going to need that as a feedstock to come back into new battery development. We're just not going to be able to mine enough raw materials to develop that kind of battery demand, in the next 10 years. So I think recycling is going to be really a critical aspect of being able to grow all of the battery space over the next 10 years.
Yeah, and that ties into another question that came in the chat box, and it said, and I'm not a chemical engineer, so yeah, forget me if I've got my tables wrong here, but it says future battery chemistry is focusing on non-CO based chemistry like LFP, LMNO, etc., which is less valuable, almost not economical as per the current recycling technology. In that case, what is the battery recycler's perspective? Require government subsidy or process development to recycle economically?
I think, Keith, going forward, this is definitely, a possibility that such challenges will be faced by battery recyclers and the industry in general. Looking back at the e-waste recycling industry and various other recycling industries, there has to be, a subsidy to make up for the economic viability gap that exists when recycling such chemistries. And that can only happen through policy intervention from the government side. And, let's say, following the polluter pays principle and, the whole concepts of EPR, etc., and necessary buyback and all of those various schemes that are already available and have been proven. So to answer that, I think definitely government intervention will be needed for chemistries where an economic viability gap exists.
Okay, thanks, Raman. John, you were going to say something?
Yeah, so I was going to say, if you look at the forecast right now, it's pretty evenly split between, say, NCA chemistries, NMC-based chemistries, and LFP-based chemistries. Generally, I think you'll see a lot more LFP in some of the more developing nations of the world, and for applications where cost is more vital. And that's generally less value for an LFP, if any value for an LFP. But you're still going to see a lot of the NMCs. Even if the C comes out, you've got nickel and manganese in there. So even if it's an NMX, you've still got materials that you're going to be able to pull out of there. So I think that there's still enough of those, and those aren't going anywhere. That's the wonderful thing about the battery industry, right, is over the last 200 years, no chemistry that's ever been created has ever gone away. So they're all still here. So I don't think we'll see, any one of them disappearing. So there will be chemistries out there that still do have a good amount of high value materials for recycling.
Yeah, and I think that comes back to a point that Raman also made. So, whilst I don't believe that EPR regulations is the silver bullet, I definitely believe it can add value to the process for all. So it ensures that stuff does get recycled responsibly, and it does create a financial incentive for people to take risks, and that's what it is. So I think it's got a role to play. It's just how you manage that properly. But I think it definitely got a role to play. Yeah. Okay. And then there's another message that says Mercury Refining LLC pays for the silver oxide batteries and other silver chemistry batteries, with many types of e-waste using embedded batteries for power source. Will batteries soon be considered part of e-waste or continue being separately designated? So obviously that regulation might differ from country to country. I'm not sure. Yeah.
Talking about India, Keith, so far the batteries from electronic sources was considered part of e-waste. So it was typically being handled by e-waste recyclers or dismantlers and then channelized downstream or exported to various other battery recycling facilities, because till recently we had very few solutions in the country. But going forward in India, we have a new set of battery recycling guidelines and rules and a dedicated EPR system for batteries now. So that's the Indian perspective here.
Yeah, thanks for that. Yeah, look, I think sorry, Justin, yeah?
Yeah, I just want to add on to Ramon. I think what we like, in general, I don't think there's going to be one sort of policy that goes across the landscape, right? I think all of us collectively would say that that would be naive if we were to say that. But I think there's going to be a lot more teeth, right? And I think that what I'm seeing, whether it's, what we're seeing discussions with the Indian government, whether it's discussions we have with U.S. government, whether it's, discussions we're having with the European government and companies within all those different ecosystems, right? And across Asia as well, is that, for the first mover in this was China, in the sense of using policy to drive innovation and standards within the industry, right? And that's, I think, you're starting to see those elements within some of the battery directive policy discussions in Europe as well, that I think will continue to carry. You're starting to see that in the US, where essentially, if you're, in order for you to be a recycler, you need to be above X amount yield. You need to be able to produce X, Y, and Z output material, right? Those sorts of standards, right? If you are a cell manufacturer, you need to use X amount of recycled material. I think you're going to start seeing, and it's going to, have slight nuances, but I think what the shift is going to be compared to kind of a simple EPR model that was historically correlated with e-waste is essentially like, how do we use policy to drive innovation? Because strategically, it's becoming very, very imperative for every company, every government, right? To figure out how to maximize the value of these materials in the overall EV supply chain, right? And so that's the one thing that we're seeing that's vastly different, is policy sort of driving industrial standards, right, from a process and an environmental standpoint.
Okay, so if I build on to what Justin has been saying, from the panel's perspective, do we need more regulatory involvement or less regulatory involvement around the treatment of batteries?
Keith, I think on the it's the answer is not so straightforward. Based on our experience, I think especially we need regulatory involvement to promote and increase standardization. That's going to aid the reuse and recycling side of things. We need regulatory involvement to create incentives to move from a suboptimal recycling process to an optimal recycling process that has both economical, environmental benefits, and both in terms of being able to hold on to these strategic materials like cobalt, nickel, lithium, and many other materials that are there in the recycling stream, to hold on to that within the boundaries of a country. So we need regulatory involvement to incentivize offtake of recycled material. So I think definitely for these three things, I feel regulatory involvement is important.
Okay. Thanks, Ramon. John, you were going to make a comment?
Yeah, no, I was just going to add to that in the U.S. I'll say, and it's not an easy question to answer, right? More or less government involvement. But one of the things that we've tried to do in the U.S. here, one of the other organizations I'm involved with is called NATBAT, the National Alliance for Advanced Technology Batteries, but it's industry trade group. And we've got all of the OEMs here in North America that are actively engaged in it. So we started working on recycling strategies at an industry level, way before the government started getting involved with it. So we're actually driving the regulations back into the government. And the same thing with like the Society of Automotive Engineers. We're trying to drive it kind of from the industry back to the government. So we've got processes and we've got regulations that the industry has not only bought off on, but helped develop.
Yeah, great. Yeah, thanks very much for that, John. We've got 5 minutes left, so we need to start wrapping up. So my takeout from what has just been said is there is a place for government to be involved from a regulatory perspective, because I think by default it creates sort of a level playing field for everybody, because otherwise you have one person spending all the time and money doing something and setting the standard, and some fly-by-nights come in and undermine that. So I think from that perspective, it could be a good thing. So we'll see. I think what also taken out today is that there is opportunities. There is positives, both from an environmental point of view, from an economic point of view, flowing backwards through the reverse logistics process. I think that's what I'm sensing, once again, there is a need for improved consumer awareness around the treatment, the handling, and the challenges from a battery perspective. Would that be a reasonable summary?
So.
Yeah, I think
sounds right on.
Yeah, I think the only thing I would add is just, or highlight, right, is the from the regulatory standpoint, is there's a large safety component in this, right, and so that part of the regulation I think is critical, right, so the handling of these batteries, both from a transport standpoint, from a processing standpoint, is really critical, and I'd love to say the private sector would solve and get ahead of those, and certainly there is an incentive to do so. But historically, in almost every industry, right, there's an oversight component, right, that's critical. So I think that is really important, and you're seeing that whether it's battery manufacturing, you're seeing the recycling side, and so and that safety is also correlated to the environmental side, right, as it relates to how environmentally friendly your process is.
Great, thanks. We've got 2 minutes left, so a quick final comment from each one of you. John?
Yeah, no, I think that the biggest opportunity is still to be seen in the recycling industry right now. Like I said, there's a lot of opportunity coming up in the future here, and there's going to be a huge demand for those materials to come back into the industry.
Great, thank you, Leon.
Yeah, I think I guess just finishing up on the last point we made, fundamentally, I think there needs to be some input from policymakers to make sure that all types of batteries are being rejuvenated, almost maybe more so than recycled, that we're capturing enough of the material from the batteries, because if at the end of the day our aim is to lower the impact or the reliance on mining and stop these things going into landfills. So but I think that we're all moving in the right direction, and all the teams on the call are doing a great job.
Thanks very much, Leon. Roman, quick final word.
Yeah, I think policymakers are going to play an important role. So I am of the opinion, and definitely we need to, through policies and both the public sectors and the private sectors working together, the policymakers, the recyclers, the OEMs working together, they need to ensure that we promote technologies, processes, innovations that are extremely rewarding in terms of a carbon footprint, in terms of price benefits, in order to create better accessibility to technologies. For developing nations, we don't have the luxury of skipping 2-3 stages of evolution and directly be extremely optimistic about adoption of high cost technologies. So
Right.
I see an opportunity for businesses there as well.
Thank you, Raman. Justin, very briefly.
Yeah,
final
I think
word?
I would just close in that obviously as a collective, both on this panel and certainly the audience members and anyone working in this industry at large, right? We're trying to solve very, very large problems that are exciting, but very challenging as well. And so whether it's with folks that you know or reaching out to other folks within that battery ecosystem, the supply chain, the more collaboration that we can have together to solve these problems and create efficient solutions, the better off we all are.
Great, thanks, panel. You've been a great panel to work with. I think the listeners have learned a lot, and thank you very much. It's been great working with you. Swanli, I hand back over to you to close up.
Thanks, Keith.
Thank you, Keith. First, I'd like to thank all the panelists for a very engaging conversation. It's an hour, and still I think there's a lot to be discussed, and that was a great discussion. Thank you so much, Keith, for moderating the session so well. And this is the last panel discussion, and I'd like to thank all those who attended various sessions throughout the day. The networking facility will be available for a few more days, so we encourage you to take advantage of this opportunity to meet industry colleagues and potential clients as well. Once again, before I close, I would like to thank our gold sponsors, OSEI, Madinat Al Nokba Recycling Services, Ulster Shredders, and also our silver sponsors, Exigo Recycling and eCyclics. Thank you all. Thank you all the panelists.
Thank you,
Thank you very
everyone.
much.
Thank you very much.
Thank you, everyone.
Bye-bye.